Sessions 24 and 25. In-process inventory. Inventory can be broken down into four types. In-process inventory are materials within a process, either being modified during a process step or waiting in a queue for the next process step. Raw materials are unprocessed materials waiting to be input into a process. Finished goods inventory are the final outputs of a process waiting to be sold and delivered to a customer. Some of the benefits of reducing inventory. Inventory ties up cash. Reducing inventory increases cash flow. For companies facing cash flow shortages, reducing inventory can be critical. It takes time and effort to track and manage inventory, increasing cost. Inventory can be damaged, go bad, or become obsolete, increasing cost. Inventory takes up space. Freeing up space will make it easier to streamline the physical layout of your processes. Many of the same actions that reduce cycle time will also reduce in-process inventory. The section on in-process inventory is partly redundant, but it reinforces the benefits of reducing cycle time. Understanding why we have inventory will help us to find ways to reduce and minimize inventory. Some reasons why we have in-process inventory. Processes take time. Inventory needs to be within process steps during processing time so it can be modified and have value added. Processes often require a number of tasks to be completed in a particular sequence. In-process inventory allows multiple tasks to be performed at the same time to increase throughput. More people working at the same time can increase throughput, but may also require more inventory. Queue inventory is needed as a buffer between process steps when the process steps have different cycle times, and it is desired to keep all operators busy at all times. Let's say process step 1 is slower than process step 2. One way to make sure process step 2 stays busy is to build up a buffer of inventory between steps 1 and 2 after hours. Queue inventory is created when processes are done in batches. The larger the batch size, the greater queue inventory will be. In this example, the batch size is 10. Each step processes a batch of 10 chairs before moving to the next step. As mentioned in Session 16, queue inventory may accumulate before bottleneck process steps. For class exercise 14, the operators counted the units of inventory within a process in order to calculate the cycle time of the process. For class exercise 27, the operators will split the inventory by queue inventory and process step inventory. This will highlight for the operators how much inventory is having value added and how much inventory is sitting idle, consuming space and cash flow. For many operations, most of the inventory is queue inventory, which means there is a lot of opportunity to reduce in-process inventory, reduce queue time, free up space, and generate cash flow. If there happens to be a small amount of queue inventory within a process, then reducing the inventory for that process probably does not need to be a priority. Rearranging the process formula we discussed in sessions 11 and 16 can help us to find ways to reduce inventory. Rearranging the process formula says that in-process inventory equals cycle time times throughput. This tells us that reducing the queue time of a process will reduce queue inventory. Reducing processing time by combining process steps will reduce in-process inventory. In other words, reducing cycle time will usually reduce in-process inventory. To reduce in-process inventory, we use the same methods we use to reduce cycle time. Queue inventory can be reduced using the same methods for reducing queue time already discussed in session 14. Reducing the transfer batch size between process steps by using equipment such as conveyors. One of the justifications for large batches is to reduce the number of setups. So, reducing setup time may allow transfer batch size to be reduced. In other words, reducing the cycle time of setup by 1/2 may allow batch size to be reduced by 1/2. Balancing a process so that all process steps have the same cycle time reduces the need for buffer inventory between process steps. Identifying and eliminating bottlenecks within the process will reduce the queue inventory that accumulates before a bottleneck process step. Issuing inventory to a process at the same rate as the throughput of a bottleneck process step will reduce the queue inventory that accumulates before a bottleneck process step. Combining process steps so they can be performed concurrently instead of sequentially. In this example, combining process steps reduces the inventory by 2/3. The operators should now understand that many of the same activities that reduce cycle time will also reduce in-process inventory. In class exercise 28, the operators reflect on the suggestions they gave in class exercise 18 to reduce cycle time to determine if some of those suggestions will also reduce inventory. This will reinforce the value of reducing cycle time. It will also show them that they already know how to reduce in-process inventory. Part 2 of the exercise has the operator identify which processes have a lot of queue inventory. This will help to locate low-hanging fruit for reducing queue inventory and cycle time. Part 3 of the exercise asks the operators for ideas to reduce in-process inventory. This will generate more ideas for reducing process inventory and cycle time. In session 26, we will discuss raw materials inventory.